Lighting can be one of the most important factors of making your scene look presentable. Oftentimes, you can spend hours on a model, but none of the detail is visible at render because it's either too dark or too bright. For this, we're going to go over a very simple way to make sure your lighting setup looks good: 3-point lighting. 3-point lighting is a standard setup for lighting that has carried on through the ages as one of the best ways to light a scene in film, photography, painting, and now digital graphics. Let's go over exactly what it is, why it's so good, and how to set it up in Blender. 3-point lighting consists of 3 lights, hence the name. These lights are called the key light, the fill light, and the rim or backlight. Let's go over each of these real quick. The key light is the main light. It's the primary or key light source. So when someone looks at a scene and says, "Oh, the light's coming from the top left-hand corner," they're most likely referring to the key light. That's the light that defines the light source in the scene. Now, the fill light is the one that sort of fills or softens the shadow that the key light casts. It's usually the least bright light in the scene, but it's very important. The fill light acts as a way to keep the shadows from being too dark on your subject. That way, you can still see those details and soften the contrast that the key light makes. The third light is called the backlight or the rim light. Now, this, as you might be able to tell from the name, is cast onto the back of the subject. Usually, it's actually the brightest light in the scene, but it's there just to give a sliver of brightness around the edge of your subject. This gives the subject an outline or a rim of light, which helps it stand out from the background. So, let's try to recreate this in Blender. Instead of our default scene, let's go ahead and replace our cube with a monkey. To do this, simply left-click select your cube and press the delete key. Then go to the Add menu at the top, go to Mesh, and select Monkey. We're also going to right-click it and select Shade Smooth. Now that we have our monkey in our scene, let's get our 3 light sources set up according to the 3-point lighting technique. We already have a light here, but if you don't, you can simply add it through the same Add menu, but go to Light, Point Light. I'm going to go ahead and treat this first light as my key light. Let's use the Move tool in the Quick Tools bar to bring our lamp to the top left-hand side of our monkey's face. Now, you may notice that our scene is not showing any actual lighting effects. That's because we're in solid mode. To see how our light actually will look at render, let's go ahead and change our viewport to rendered mode. You can do that by going to the top right and clicking the rightmost sphere, or pressing the Z hotkey and using the pie menu. Now that we can see the effect of our light on the monkey's face, we can adjust the light a bit more as needed. If you would like to adjust the brightness of your light, simply go to your Light Properties tab, indicated by a green light bulb icon, in the Properties editor. You can then edit the power of the light by left-click dragging, or you can left-click tap the property and type a number manually. I'm going to go ahead and leave this at the default value of 1000W. Next, we'll make our fill light. Now, as long as you have one light, it can be very easy to make more, as you can simply select the first light object and press Shift-D to duplicate. With this new light, let's place it on the other side of the key light. If the key light is a little higher than the monkey, make sure to place the fill light a little lower. However, it seems a bit too bright on both sides. If you remember from our previous descriptions, the fill light is meant to be the dimmest light in the setup. I'm going to go into our Light Property tab and slide our power value down with left-click drag, all the way down to 0. Then I'll slide it right back up just a little bit to a point where I feel like it's bright enough, but not too bright. That's perfect. Now we can finally add our back or rim light. Let's create a third light object in the same way we did before, and place it behind the monkey's head. For now, we can place it directly behind the monkey's head, but oftentimes it is a bit off-center depending on where the camera is. Feel free to experiment with this to get the best outline shape for your subject. Now, if you remember, the rim light is typically the brightest light in the setup. So let's just start off by dragging that power slider in the Light Properties tab as high as we can get it, until we see that bright white outline around our subject. Just to save you some time, I'll say that the number I decided to use was around 50,000. Definitely the brightest light, but feel free to tweak the numbers based on your scene. Awesome! Now you have your 3 lights set up, and it looks pretty decent. However, let's add a cube to act as our environment real quick. To do this, simply go into the Add menu of the viewport, go to Mesh, and select Cube. We can then scale the cube up with the Scale tool until we find ourselves inside of it. Now, you might notice something a little weird. Our cube is almost completely white. What's happening here is our environment is now super bright because of our lighting setup. This isn't very ideal, especially if you want to have your character stand out. One reason for the environment being so bright is because we're currently using point lights for our light sources, meaning that they cast light in all directions. In film and photography, the physical lights used are typically directional lights, specifically to avoid this problem. Let's try to do the same. Starting with our brightest light, the rim light. If we select it with left click, we can go into the Light Property tab to see other light options: point, sun, spot, and area. Feel free to experiment with each light type, but I personally like the spotlight for this purpose, as you'll be able to focus the spotlight column as needed. Simply select the spot option, and you'll already notice a difference. Our environment is more clear, but our monkey's rim light is no longer there. That's because our spotlight is currently rotated the wrong way. Let's use the Rotate tool to point it back at our monkey. Now, because this is a spotlight, you can also adjust your spotlight's effective area by dragging the size value in our Light Property tab. Awesome! Now our backlight still has the same effect it had earlier, but without the issue of overlighting our environment. Optionally, you can do the same thing for your other two lights, but this can be situational, so feel free to experiment and adapt. And that's it! You now have a beautifully lit monkey in Blender. Rendering in Blender is the part where you finally get to pump out your animation or still image out of Blender and into a beautiful image or video. To see how this all works and what options you might have for this process, let's go into the Render Settings tab of the Properties editor. This is labeled with the backwards facing camera icon. This tab can be a bit intimidating, so in this video we'll be introducing the important settings and going over some specific ones in the next few videos. But before we go over anything here, you'll want to learn how to render. To render a still image, go to the Render menu in the top left and select Render Image. To render your entire playback range, simply go into the same Render menu and select Render Animation. For hotkey users, you can press F12 to render an image and Ctrl F12 to render an animation. Now let's go back to our Render tab and do a quick overview of some of the settings that will affect these renders. The first setting is your render engine. This is a drop-down menu with 3 different engines: Eevee, Cycles, and Workbench. The differences in each engine are covered in the Introduction to Shading video, but I'll go over them once again. Eevee is your real-time render engine. This is currently Blender's default engine and is node-based, just like Cycles. In fact, Eevee and Cycles can share nodes between each other. This means you can often preview your shader in Eevee and render in Cycles later. Why would you want to do this? Because Cycles is a more accurate, more realistic engine, but takes a lot longer to render. Workbench is Blender's preview render engine. It is technically the same engine that drives solid view in the viewport, and so you know generally how it looks, but Workbench as a separate render engine exists so that you can keep your render output settings for your preview animations the same while still being able to work flexibly in the viewport. Depending on what engine you have selected, you will see different settings below. I'm going to quickly go over each one, but I do recommend experimenting with these settings when you can. Let's start with Eevee. Immediately you'll see a sampling setting, which allows you to set how many samples Eevee will take during render, both in viewport and at render time. The higher the samples, the more accurately the engine will calculate your shaders. Both Cycles and Workbench have this setting as well. Next, you'll see a few things that will directly affect a lot of the visual aspects of your render, namely ambient occlusion, bloom, depth of field, subsurface scattering, screen space reflections, motion blur, volumetric, hair, shadows, and indirect lighting. These are engine specific, and I recommend you play around with each one as their settings can go quite deep, but their names should make it self-explanatory what they will affect. To test them out, simply go into Rendered View in the viewport and adjust freely. Just so you know, for some of these features, such as motion blur, you'll have to enter the camera view. Film is a setting that is shared by all three render engines. One of the most used settings in this category is the transparent checkbox. This affects the sky. If you click transparent, Blender will automatically replace the sky with full transparency for your output image. Simplify is also a shared render setting between all three engines. It actually pertains more to the scene itself, but does have settings that can affect render. Basically what it does is disable subdivision modifiers past a specific value to reduce the overall poly count of your scene. This is typically used to help the viewport run more smoothly, but also has a value to specify max subdivisions at render. Freestyle is a powerful tool that allows you to do non-photorealistic outlines and strokes in your render based on a plethora of different settings. However, this checkbox is to simply enable it at render. The real freestyle settings are in the View Layer tab. Freestyle is also available in Cycles, but not in Workbench. And finally, we have Color Management, which is also available for all three render engines. This one is pretty self-explanatory. It manages color. Feel free to experiment with these settings as they will affect how your colors are interpreted for your output render. Now, if we switch over to the Cycles render engine, you'll see that the options we have are slightly different. The first thing you'll notice is the ability to switch between CPU and GPU. This is a very important setting for those wishing to take advantage of their graphics cards to decrease render times. If you don't have GPU as an option or it's grayed out after selecting GPU, you might need to go into your preferences, go to System and select CUDA. If your graphics card is not listed underneath here, it may not be supported. But if it is, make sure it's checked and then go back to your GPU-CPU dropdown and it should be working just fine. Sampling works the same as Eevee, but has a few extra settings you can play around with. Light Paths gives you options to change the accuracy of the light in exchange for render times. The volume and hair settings will affect the quality of volumetric shaders and hair particles respectively at render. You can see these in the rendered viewport for testing, but motion blur is not real time for Cycles. For that to be visible, you'll have to render an image by pressing F12. Performance is an important setting for Cycles, especially if you're switching between GPU and CPU rendering. Tiles are what Blender divides your image into. During render, Blender will complete the render of a tile or chunk first before moving on to the next one. The most efficient way to divide up your render depends on each shot, but the general rule of thumb for CPUs is to keep the tile relatively small, as CPUs can render multiple tiles simultaneously. Default settings usually work great for CPU rendering. However, for GPU rendering, the general rule of thumb is to keep the tile large, as it only renders one tile at a time. So you'll want to adjust the tile size accordingly. For GPU rendering, I typically recommend a tile size of 256 by 256. There are also a few other settings you can play around with. And finally, the Bake category includes the Bake button. This button is used to bake lighting into textures so you can use them instead of recalculating the lights every time. Now let's go over the Workbench settings. But if you're already familiar with the Viewport Solid View settings, you'll find these to be very similar. Workbench also has sampling, but generally it does not have to be very high, especially since Workbench is mostly for preview renders. As usual, if you want to see how each of these settings affects your render, simply go into rendered mode in the viewport and tweak them as you like. The Workbench specific settings here are lighting, color, and additional options. Lighting allows you to change how your scene is being lit. Studio is your default, and you can choose different presets by clicking on this sphere. You can also click the globe icon to rotate the light source direction. Matte Cap is another great way to see your scene very clearly, especially during sculpting or modeling. More Matte Cap presets can be found by clicking on the sphere. Flat is just giving all your objects a single color with no lighting. The color settings allow you to change the color of the objects in your scene based on different parameters. My favorite option is the random option, as it gives every object a random color and makes everything super easy to see. Under options, you'll have miscellaneous stylized options that affect your scene visually, such as X-ray, shadows, depth of field, and outline. That's it for the Render tab settings. However, there's also much to be learned about the related Output Settings tab right below it. This is labeled with the Printer icon tab. Here is where you'll be able to change information regarding your render output file, such as resolution, file path, file format, and metadata. This tab is not render engine specific. Now that you've gotten a general idea of what these render settings are for, I'm going to go a little bit more into detail about some of these settings in the next few videos. Dimensions and metadata are two settings that can be found in the Render Output tab. This is labeled with the printer icon in the Properties editor. Dimensions simply refers to the resolution of the final output image. For example, most HD images and videos are 1920 pixels by 1080 pixels. You can set your resolution by left-clicking the number and manually typing a new one, or you can left-click drag to slide the value left or right as you see fit. It's important to know that when you change your output resolution, the shape of your camera will change to match the aspect ratio of your output resolution. This percentage value represents your ability to reduce the resolution very quickly for, say, test renders. If you want a 1080 final output, but you want your next few renders to be test footage only, you can reduce the resolution with a percentage factor to minimize render times and file size. The aspect slider is simply another way to quickly multiply your X or Y resolution values by a scalar. Render region is a checkbox that is very important if you want to only render a small region of your camera. However, you'll notice that if you check this box, nothing actually happens or changes, except when you go into camera view, your camera is now outlined in a dotted red line. That's because currently your entire camera is selected as the region you want rendered. To change this region, simply go to the View menu, go to View Regions, and select Render Region. This will give you the ability to draw a rectangular area on your screen to specify which part of your frame you want rendered. This will become represented by the dotted red line. For hotkey users, simply press Ctrl B to begin drawing your render rectangle. It's important to note that if you draw a render region with the Render Region checkbox turned off, it will automatically check this box for you. To clear your render region and simultaneously turn off the render region checkbox, simply go back into the View menu, go to View Regions, and select Clear Render Region. For hotkey users, simply press Ctrl-Alt-B. Crop to Render Region is a checkbox that will reduce your image dimensions to match the render region dimensions. If you don't have this checked, the final output image will not be reduced, and will still be the same dimensions as it would be if it rendered the whole image. However, only the rendered region will be visible, with the rest of the frame being transparent. The frame start and end values are the same values you see on your timeline. They are synced, so changing the start and end frames of your playback region in one place will affect the other. The step value will affect how many frames you step forward before rendering the next frame. By default, the value is 1, which is the minimum value. This means that it will render every single frame. However, if you decide you only want to render every 2 frames or every 10th frame in the timeline, you can specify that here. This does not affect viewport playback, however. Frame rate is simply how many frames per second are meant to be played during playback. This can affect both viewport playback and rendered animation playback. Time remapping is a setting that will help you very quickly retime your animation to be faster or slower, stretching or squashing the existing keyframes based on the ratio you provide. Time remapping is not very commonly used, but can be used to quickly retime your animation to be faster or slower at render. Stereoscopy, roughly meaning 2 eyes, is basically the thing that makes 3D glasses necessary at 3D movies. It's a big topic, but to create a stereo 3D output, you'll need to enable this checkbox. You'll immediately notice options for the left and right eyes, which allow you to specify your preferred suffix for the file names, as each eye will need to be a separate image. Fun fact, you can also go into camera view to see how your scene might look in 3D, assuming you have some basic red and cyan 3D glasses. Metadata is another output setting that allows you to include additional information and stamp it onto your output file. If we open up this category here, we can see there is date, time, render time, frame number, etc. You also have the option to include a custom note. Now, right now, if we render our scene with the F12 hotkey, you'll see Blender render out a simple image of our camera perspective. However, there is currently no metadata visible. To show the metadata and include it in the output file, simply check the Burn into Image checkbox. Feel free to tweak the settings there, such as font size and transparency, to your liking. I hope this video gives you a good idea of how the dimensions and metadata settings affect your render. We'll go more into the file output settings in the next video.
Shut up and sit down.